Hello, everyone. I'm really happy to co-host this live session today with Kuba. Hi, Kuba.
Hey there. Hey, everybody.
And and today we're gonna talk about Web3 Glossary. Glossary, I mean here some important phrases, acronyms, and yeah, all the buzzwords that are relevant in the Web3 space. This live stream would be more for beginners, more for the people that would like to start their journey as a front-end or back-end developers and touch a bit smart contracts. I think it's really important to actually grasp basics, some basic words, especially if you would like to read through documentation or listen to some podcasts or watch some video courses. It's very important to actually know some basic phrases, basic words, and we will try to explain them today for you. So we'll start maybe with Kuba. Kuba, which phrase, which word would you like to start with?
Yeah, the node or RPC provider. So
Okay,
I'm going to explain that term for you. And
sure.
if you if you want to become a Web3 developer, that's definitely must have. This is the first thing you hit is RPC provider, RPC node. So if you try to connect to whatever chain, you need a specific URL. For purpose of this live stream, let's say it's URL. So I want to connect to Polygon. I can use whatever URL from this list, and this is my gateway to the to blockchain. But keep in mind, it's kind of centralized. It's bottlenecked with blockchain communication. So, and there are free providers, and if you if you want your application to be more trust, you want to rely on some company who provides a professional service in terms of RPC nodes. I recommend using Alchemy or Infura. Infura is considered mostly as the RPC provider, and Alchemy it's starting to be a developer platform for Web3 development. So it's not only about RPC providers, but also for other stuff.
Yeah, it works basically as some kind of analytics because you can not only read or write information through this gateway, but also you have some kind of your internal account as a developer, and you can track, for instance, which transactions were made through your gateway. So it's also nice to get some analytics about your users, about to see which transactions are more popular and so on. So Jakub, would you like to add something to the RPC nodes, or can we go
Yes, yes.
for
One,
more
one,
for next phrase?
one more sentence is using some public RPC providers. You have no control and you have no privacy because everything goes through that node provider, and someone who pays for actually that centralized server see that person sees the logs of everything you do on the in the network. So if you want to have a control and if you like to say that this node provider is mine, they need to use some professional services dedicated for RPC providers, for professional
Mhm.
software.
Yeah, and it's worth to mention that as a developer of the decentralized application, you cannot force your customers to use certain gateway, to use certain RPC node, because your customer, your client, can basically decide which RPC node they would like to use in the wallet configuration. So it's worth to mention that every user of the blockchain network is independent and can make own decision about which RPC node you would like to use within your wallet. Okay, so I will go maybe with next word, next phrase that was, I think, quite often mentioned on this channel already. It's smart contract. Smart contract is software that is basically deployed not to some centralized server, but rather into the network, into the blockchain network. So for example, if we are on the Etherscan, which is a blockchain explorer, you can see that there are a lot of transactions that are sent to the network. And some transactions are very simple, that they are just saying, okay, send this amount of Ether to some other address, but some of the transactions are more complex and they are interacting with this code that could be deployed to the blockchain network. And for example, the most often smart contracts are smart contracts that are responsible for holding informations about the tokens. So for example, if we have token like USDT, which is a stable coin, or if we have some other ERC20 tokens like Matic, these are the smart contracts. So they are basically a super small source code deployed to the to the blockchain network, and this smart contract, this code holds information about the balances. So for example, if I have here some USDT token, I'm able to transfer, I'm able to check the total supply balance of, and I have some functions, I have some interface of this smart contract, and this smart contract is deployed to this blockchain network, and I can interact with the smart contracts using their addresses. So it's a bit weird at the beginning to understand that if you want to send money to your friend, you are using address. And if you are interacting with some tokens or NFTs, these are also the addresses. So this might be confusing at the beginning, but it's just how the blockchain like Ethereum works, that no matter if you are interacting with the smart contract or real person, then you are always referring to the address. So that's the smart contract. If you have any questions to that, feel free to ask. And now I think Kuba can tell us something interesting about ABI, right? You are muted, Jakub. Yeah.
Yes, right. And in terms of Etherscan, that's probably the most interested tab is a contract tab where you can find information, where you can find source code, as Arthur mentioned, and there is also ABI. And ABI is the next term I like to explain to you. And what is ABI? And ABI basically is a JSON file, JSON code. So let's make it a little bit nicer if we can. We're not JSON. The formatter doesn't work. Okay. It looks like this. This is not the pretty version.
Okay. Yeah, you can. Yeah, you can use some VS Code plugins for that. I have some beautified JSON or stuff like that.
It's better. It's going better. Okay. So we have there is a JSON. Maybe it's not valid JSON. It's
you can
array.
save it. You can save it as a JSON file because right now it's TS, and if you save it as a .json, I think I'm in the extension in the VS Code.
I broke something up. Um, oh no, okay, it doesn't work. But even here we see uh, we have some items. We have some array with some items, and each item is a signature of smart contract method. And you need that API on your front end side. Let's say in terms of front end, developing front end, you need to have that in your source code to be able to encode and decode the communication with your smart contract. Um, so there is a lot of layers, and one of this layer is API. If you want to send transaction to blockchain, you need to have a function signature. So function, it could be a one item from this API. You need to take this item, put it into provider, and provide an address to your smart contracts, and everything. And this is everything. You need to combine everything together, put it together to one bucket, and then you can send that to your wallet and send a transaction. That's one case.
It's very popular to actually a very frequent question from the front-end developers where I can get ABI from, or can you send me the ABI? Because this is basically needed for front-end developers whenever they want to read or write something to the smart contract. You cannot do it if you don't have the proper ABI. And also, it's good to have it because some libraries like Ethers, WAGMI, or some others that are simplifying access to the blockchain, they are also doing some validations for you. So, for example, if ABI states that function takes 3 or 4 arguments and you are trying to pass 5, then you can immediately have an error that you are not passing the right arguments.
Yes. And if you like to have ABI always on time, care about your relationship with your smart contract developer.
Yeah.
Otherwise, you need to grab it from some other sources, and the most relevant source is Etherscan. But ABI to be available on Etherscan, the contract has to be deployed. So you cannot obtain APIs for not deployed smart contracts.
Oh, you deployed for sure, right? And also not verified, right? If smart contract is not verified, just deployed, then you won't get ABI here from here. This is also important step.
Sure. So maybe we can jump into the next step. Something for you, Arthur. What about transactions and events? What's that?
Sure.
Why we need transactions? Why we need events? What it does?
Okay, I will explain it again using Etherscan. I think we'll use it on this live stream couple times at least. So Etherscan is a great blockchain explorer, and here I just found some random NFT project. You can just go NFT, stop NFTs, and then you can see smart contracts that are NFTs. They are holding information about some tokens like Mutant Ape Yacht Club or Captains or whatever other projects you can find here. And if you click on the name of this particular NFT, you can see that it's the smart contract which has some transactions. So, for example, we can have this NFT and we have list of transactions. So the list of transaction represents every transaction that was sent to that smart contract. So for example, if I want to send you NFT, I'm not actually sending a transaction to your wallet. I'm sending transaction to the smart contract that holds information about which token is held by which wallet. So this is something that sometimes at the beginning it's a bit hard to understand, like why there is no transaction to your wallet if I'm sending you an NFT. Why I have to send the transaction to the smart contract, and the reason for that is that obviously your wallet doesn't have any logic that is responsible for handling NFTs, because this code, this logic is available only on the smart contract. And here we can see all the transactions that are sent to the smart contract representing NFT. We have multiple transactions here, for example, set approval for all transfer from. So every transaction can actually represent a different function call. And this is about the transactions, right? So we have the smart contract or wallet, and we can send some transaction to the given address. Of course, every transaction has some price, has some fee that we have to pay, but this, I think, Kuba will explain you in details in the seconds. But one last thing that I would like to cover, besides some transactions, is that some transactions can emit events. And events are super important to the developers, because if you have some important change of the state in the smart contract, you can emit a log, which is called event. And then these events can be read publicly by anybody who is previewing the blockchain network. And these events are very interesting because you can listen to these events and react to them. And this is especially interesting in the DeFi or NFT world, because, for example, if I have this particular NFT and I'm trading it to you, then some external systems might be interested in that. For example, OpenSea or some other marketplaces can be interested in certain events, for example, to change their UI, that I'm no longer this NFT owner, Kuba is the new owner, right? So this is just one of the examples where events are important, because some other applications can just change their state after some event is emitted. So some standards like NFTs or ERC20s, they just have some events that are built in. But of course, if you are developing your own smart contracts, you can decide when and which event you would like to emit. So that's all. And yeah, what we have next on our list.
Yeah, I like to add that events are the cheapest way to say something something happened on the blockchain without actually saving anything in the blockchain state.
Mhm.
So and if you want to analyze what's happened in the network, you probably I'm sure you collecting events. So for data analyzing, that's the crucial thing. The next term is, what is the next term, Arthur? It's gas.
Yeah. It's very,
Yeah.
very important thing. Often, I think, there are some misconceptions about it. Yeah, so I think it's really important to cover what is the gas exactly.
Yeah. I don't know what about you, but for me, is the most interesting thing of the stream, talking about gas. Gas is gas fuels smart contracts executions, gas, fuels, transactions. So whenever you make a transaction on blockchain using your wallet, you need to you have to burn gas. It's a good term, Arthur. You think burning is it's reserved for burning tokens? It's another term. Okay, let's say some gas needs to be burned to make your transaction to be executed, and uh, the more complex is your transaction, if there is a lot of code, a lot of logic, some loops in your smart contracts, then the gas you need to pay for is going to be really high. And there are two factors. So that was the first factor, that complexity of your smart contracts. And another factor is what's the situation in the market. If there is a lot of transactions sent to in one block in certain moment at once, then validators want to earn more because the demand is really huge. They supply their service in higher prices. So the more transactions now on the blockchain, the gas price, this another term, is higher. And if you multiply gas price by your smart contracts complexity, then you get the cost of execution of your smart contracts. For example, we have 56 GUI for a gas now, which is pretty high. And let's say my contract uses 1 million units of gas. So I need to multiply those two values to get the actual ether needed to cover my gas fees, because gas is related to gas fees. That's the cost of participation in the network. So you need to pay to contribute.
Yeah, and I think it's worth to mention that because often people that are entering the Web3 space, they don't get why you have to pay this gas. And I think a lot of people are complaining that, okay, what's the reason of using this blockchain at all if I have to pay whenever I want to save something? And I think it's, just very important to understand that these gas mechanisms actually, they are guaranteeing us that the network is stable and safe. Because if you would allow anybody to write information into the blockchain for free without paying any fee at all, then it would be really easy to just spam the network, right? Because then somebody can just issue billions of transactions per day if that costs nothing, and then say, okay, your network, your blockchain is super slow. But if you have to send a transaction whenever you are deploying smart contract or whenever you are interacting with or writing something into the smart contract, you have to send the gas fee, and this gas fee, part of it is just burned, so nobody else can use this ether anymore, and some part of it is going straight to the miners, so to the people that are actually validating your transaction and then putting these changes into the blockchain. So it's very important that actually always somebody needs to pay the gas because otherwise the whole network would be very easily to make it unstable.
Yeah, and gas prices are related strictly to the market. The block capacity is limited, so you cannot put more transactions into one block because of the capacity is it's limited. Then you need to pay more to be first in that block. So market rules.
Yeah.
Okay, Adam. Sorry, I confused that with my colleague Arthur.
Yeah, of course.
Arthur,
Yeah.
the next term is
Then
not the screen. The
yeah,
next
the
term
next
is
chain, I think.
chain. Chain, yes.
Yeah, so chain is actually also another confusing thing in the Web3 space, because especially at the beginning, when people are starting learning how to use Ethereum, how to make the smart contract, then all of a sudden you hear something about Polygon, about Girly, about Binance Smart Chain, and many other chains. So this is also something confusing. Because in the Ethereum world, we have layer 1, which is the main Ethereum mainnet, and we have layer 2 solutions. And layer 2 solutions are basically just something, some different chains. And what it actually means is that you have to imagine that Ethereum mainnet is just a separate network. So if you are using some different chain like Polygon, it's completely different ecosystem. You can pay different gas fees. You can have some different speed or bit different rules, a bit different size of the block even between these networks. And for example, if you have some funds or if you have some NFT on the Ethereum mainnet, it's not working like that you have exactly the same assets or the same state of some wallets or smart contracts on the different chain. So if you ever see the word chain, I think it's often replaced by network. So, for example, some applications can even state that, oh, you are on the wrong chain, because they expect you to be on the Polygon or Binance Smart Chain, or they sometimes UI states like change your network because you are currently on Polygon and we expect you to be on the Ethereum mainnet. So I think often these two terms are just used in the documentation or in some user interfaces. And I think at the beginning of your journey, you can focus on just building stuff for Ethereum mainnet and Ethereum testnets, because the development process is basically the same across these networks or chains that are Ethereum compatible. So for example, if you have a smart contract or transaction that works on the Ethereum mainnet, it would work also on the Polygon. You have to be just sure that you know exactly which network you are using, and also that the RPC provider that you are using is also configured to the same network that you expect to use. Because sometimes developers are deploying smart contract to Ethereum Girly. They have address of the smart contract, and then after couple days they try to interact with this smart contract on different chain, on Ethereum mainnet, or they just try to connect from a different network. And then of course you can have some errors because the smart contract that you meant to communicate with is just exists on the different network. So it's really important to remember that address plus network it's always the right, let's say, place for the smart contract or wallet. It's never like you can just switch the chains and you would have exactly the same state.
Yeah, I like to think about chains like parallel universe, because you can have the same addresses on different chains, but it means something completely different. The parallel words. Something there is something similar, the reflection of something else, but looking completely different. And as you mentioned, chain plus address is the actual address of some unit on blockchain.
Yeah, yeah, that's a good analogy to different universes. Okay, so I think we can move to the next phrase. Guys, if you have any questions, feel free to ask on chat. If there is any word, any phrase that you think is hard at the beginning of your journey, then suggest it. We'll try to answer it just on this live stream. Otherwise, we'll continue with our list. And I think the next phrase is block, right?
Yeah, right, block. I'm already mentioned blocked in the first in my first turn, and I said blocked has limited capacity. I know how many megabytes exactly it is for now. On, for example, mm, for Ethereum mainnet, for example, but it's limited. And in that block, you can put transactions. Transaction could be a smart contract deployment. Transaction could be sending some tokens to someone else, to another person. It could be anything what happen on blockchain. And we used to think about data and computer science, data changing over time, because time is something we know, and we can refer to real world. Something is touchable. We can refer to the time and physics. That's completely natural for us. But in blockchain, data changes not over time, but over blocks. And nothing happens between two consecutive blocks. If I have block number 1000, and the next block is 1001, there is no block number 1000 and half. There is, it's like a journey, 0 to 1 always. So if you refer to certain block, you refer to one snapshot of the certain blockchain instance state. So there is always deterministic, and there is always the same for every users of that blockchain. And great, we see some blocks, some numbers jumping on the top. That's nice visualization. How often blocks are created, but this is better for me because it's there is a lot more. So you see some people staying in the queue, staying in the line, and waiting for what? For a block. You can refer these people as transactions. And so some transactions staying and waiting for being executed. And once they are approved by validators, put some transactions into block, and other validators can prove this block is correct. That's basically it, I think, and that's a good visualization what is happening. On the right side, you see Bitcoin Bitcoin blocks.
Yeah, these rules for the blocks and how they are created, they might be different to different chains. So, for example, if you are used to the mechanism that is on Ethereum mainnet, then on some other layer 2 solution, even if it's Ethereum compatible, then you can have some slight changes in the size of the block or how often the new block is created. So it's always worth to at least know that there are some differences in that. Okay, I will go for another thing to explain, which is wallet and private keys. This is, I think, also important. Here is some online tool, if.build, that you can use for simulating some operations that may happen on the Ethereum blockchains. And here is a very simple block which generates a key pair. So for example, if I click here, you can see that every time I click this button, there is a different private key generated and some different address that is tied to this private key. So of course, whenever you are generating a new wallet, which wallet is often referred to this public to this address that anybody can see, right? Because if you are generating a new wallet, you have the address that you can put it on the paper, print it, or send it to somebody over some social media or some messengers. And behind the scenes, always you have the private key. And out of this private key, there is a public key generated. And of course, behind the scenes, there is a lot of mathematics going on. So it's not easy to guess the private key out of public key. It's very hard, actually. Super hard actually operation. If anybody would know how to revert public key into the private key, then probably every possible if would be stolen already. So at the moment, it's we can say that this cryptography that is behind that key pair generation, it's very, very strong. Yeah, and the public the address is actually often used, as I said at the beginning, also to refer to the smart contracts. So if you are deploying a new smart contract, then you are sending a new transaction from your wallet, which contains the code of this smart contract that you want to put to the blockchain. And the address is actually calculated out of your address, your number of transactions that you did from your address, and of course the code of the smart contract. So that's couple of factors that are actually affecting the address of the smart contract. However, if you would like to just generate a new wallet, then there are libraries like Ethers, WAGMI, and many others that allow you to use the cryptographic function that will generate for you a new pair of private and public key. So that's how it works. Yeah, and it's very easy to do. You can just try Ethers and just be aware to not reveal your private key anywhere, because if somebody knows your private key, basically it means that this person can control your wallet. So it's very important to always be super cautious and just secure the private key whenever you generate it. And
yes, keep your private key super safe. That's the most important thing.
Yeah. And
And
now we
for
have
next term,
ChatGPT something, right?
yes, I used that the favorite tool of last weeks of maybe last year even to explain to you what is Ether. And Ether refers to native currency of Ethereum mainnet, but each chain, we talked about chains. Each chain has its own native currency, and Ether is for Ethereum mainnet or Ethereum. It's commonly called Ethereum. And what I asked ChatGPT, what's the purpose of Ether native currency, and why is it important? And I see 6 points, and first one is let's focus on the headlines. The first one is medium of exchange. Yes, you can collect Ether, you can exchange it with for some other currencies on some. It could be considered as a money. And the second point is smart contract execution. You need native currency, you need Ether to pay for gas, to pay for smart contract execution. Third point, decentralized application dApps. That's let's skip that. Nothing interesting, I think, to mention. Let's scan it. Okay, let's go to fourth point. Token sales and crowdfunding. That's definitely not interesting. Store of value. Yeah, it's self-explanatory. Governance and staking in Ethereum version 2. Ethereum after Ethereum turns into proof of stake. It means you don't need to run actual computers and pay for electricity. You just have stakers, and the more Ether you collect, you have impact of validating transactions. But you need to have really uh, for me, it's huge amount of Ether. It's 32 Ether to be standalone staker. Um, yeah, so that's I would say that's the medium of exchange. It's needed to pay for smart contract execution, and it's needed for staking. It's needed to become a staker, to become a validator. That's the three
And
main
it's
purposes.
yeah, and it's needed actually to cover the gas on the certain network, right? Because of course, interacting with the smart contract execution, it's of course one way to spend the gas fee, but you can also interact with some other wallets just by sending the native currency, right? So, for example, if I'm sending one Ether to some other wallet address, then I'm actually not using a smart contract, but still I have to cover the gas fee. And it's very important to mention that Ethereum, it's not Ether, right? Ethereum is a blockchain, and Ether is just a native currency within the Ethereum blockchain. Because I know that sometimes people are saying, okay, I will send you some Ethereum, which is not very accurate, right? Because you are sending actually Ether. And sometimes it's even more tricky with some other chains or network. For example, if you have Polygon, you have a native token that is named Matic, right? Because previously Polygon was named Matic, and now they changed the blockchain name into the Polygon, but the native currency stayed as Matic. Then you have also some other exceptions, like I think Base. Base is basically a blockchain network backed by, I think, Coinbase. And they did something that you are still using Ether, on their blockchain. But it's just like this blockchain is working completely different, like the second layer solution. So you have different prices, but still the native token is Ether. So for example, if you would like to cover some gas fee, you are still paying it in Ether, but the price is much lower than on the mainnet. So there are often some exceptions. So it's always worth to check, okay, if I'm using some specific blockchain, I have to get the native token first, and I need to know exactly what is the name of this token. And this, of course, has some user experience implications too, because often people are just choosing Polygon network, and then they still have to instruct their users how they can interact with their dApp, because some users may be super fluent with Ethereum mainnet, so they have Ethereum mainnet, they have Ether in their wallet, and it's just super convenient to some customers. But if you tell them, okay, but if you would like to interact with my decentralized application, you have to be on the Polygon, right? So this is also some kind of challenge in terms of user experience, because we have to navigate users how they can actually change the network in their wallet and why they actually have to do it. Then we have the problem of getting this native token, probably for the first time, because if you don't have any native token in your wallet, you cannot do any transaction. And you have to explain all this, and sometimes it's really challenging to explain to customers why it's different network, why you have to get native token, and the prices are different, the speed is different. So whenever you decide about this, you have to take that into your consideration and plan it in your designs, probably. Anything to add to the Ether, Kuba?
Yes, is Ether always uppercase? It should, I think. Everybody in my stream says always Ethereum. That's the two doubts that I have. Ether as a native currency is always written uppercase, and it's Ether, not Ethereum. It's Ether, and everybody in my stream says Ethereum, referring to the native currency. Everybody do that. So even I see some persons who are trying to call themselves as experts, they sometimes using the word Ethereum referring to the native currency. We are developers. We like to be strict, so we'll use the correct name every time. Do not be confused with this people from my stream. Yes, and that's everything on my side. That was the fifth turn, and the last one, but not least, is on your side is EVM. It's the second acronym. I got API, but I got RPC earlier. So actually, it's the third one. Third one acronym to explain EVM. What is EVM, Artur?
Yeah, so EVM stands for Ethereum Virtual Machine. I think usually whenever you have some phrase with VM, it's virtual machine, but you have some different virtual machines in computer science. Let's maybe put it that way. And of course, Ethereum has own virtual machine, which is basically some kind of environment in which the code is computed. And I think EVM is not that important if you are just doing some basic stuff, if you are interacting with smart contracts that are already done. I think there is not that much that you have to know about the EVM. I think whenever you have to do some more complex, more advanced stuff, then you have to know how EVM works. So if we can compare it maybe to, let's put it into traditional programming, then maybe the analogy is that Ethereum virtual machine is something like assembly, or some just some layer, yeah, some more lower level layer in terms of programming. So if you are developing in Solidity, if you are creating smart contracts, then this code is transpiled into the bytecode, and then the bytecode is executed on the Ethereum virtual machine. And it's really important to know how Ethereum virtual machine works if you are some auditor of the smart contracts, because then you have to know all these rules, how the memory, how the stack is basically working. But as I said, it's quite complex. And yeah, I think at the beginning of your journey with your Web3, you shouldn't yeah, you won't need to go too much into details how EVM works, but I think it's still worth to know this acronym, that it stands for Ethereum Virtual Machine, and it's often also used in the docs, that whenever there is some second layer solution, it's often states that it's Ethereum compatible or EVM compatible, or that smart contracts are like on the EVM. So it's quite often used term, and it refers to the Ethereum virtual machine. So actually, I have nothing more to add to it for now. Kuba, maybe.
Yeah, although it contains the word machine in the whole term, it's not a one machine. It's not a physical machine. Don't think about that in this approach. It's something really virtual. Virtual is the most important word in that term. It's virtual. It's not machine. But it, in terms of computer science, it also it's a machine. But every time when someone says machine, I um, I see some dishwasher or something like that. But it's not that one centralized computer. It's just some environment. It's a software you can run on your computer. You can run EVM on your computer. If on my daily basis, when I developing some Web3 application, I always have EVM machine running on my laptop.
Yeah, what is really actually also maybe interesting is that if you are using the Remix IDE and you are building some smart contracts, then behind the scenes, the Remix IDE, which is a web application, it runs JavaScript Ethereum virtual machine in the back. So whenever you write some code and you would like to try it, then you can simulate that on the Ethereum virtual machine, which is just running in your browser. So this is how it works. It's also, yeah, what Kuba said, it's also really important because, yeah, there is no single machine. There are just army of some machines, some nodes that are operating within the blockchain. And you have to also think of this Ethereum virtual machine that actually it has to work the same way on every node. That, for example, if you have some bytecode and you will run it on EVM my machine, and then on Kuba and some other participants' machines, then the result of running some code must be always the same. It cannot happen that you have some transaction and you are just executing it on the EVM, and on one node there is a different result that's on the other one, because then basically the whole network cannot work, because we don't have the consensus between multiple nodes. So it's very important that these virtual machines must working in the same way. So for the same input, we should get the same output. And if it's not like that, there is a clear indicator that something went wrong. Maybe there's some bad actor that tries to send some wrong transactions into the chain and do something shady. So yeah, it's more like that. There's one question from the chat. Could you make a video about most wanted skills for junior developers? I've been learning for 1.5 years. I built some basic projects and of course still learning. Yeah, I think it's a good idea for maybe another live stream where we can talk about, it's quite popular on Stack Overflow or some other places that you can find these blockchain developer roadmap or junior React developer roadmap and stuff like that. And maybe we can also cover these most wanted skills for junior developers. But yeah, anything to add to the EVM, or we are closing?
No, nothing to add. EVM, it's cool.
Okay.
Let's
So
talk about
guys, if you have any question about some other maybe phrases, or if you would like us to clarify something, then I think it's the last 1 or 2 minutes to do so. Kuba, maybe I will ask you, do you remember when you were learning front-end development for Web3 world, was there any word or any phrase that was confusing to you at the beginning?
Whoa, that's been not a few years ago. That's been a couple years ago. I don't remember really. Maybe I was confused on HTTP, REST API, virtual machine. That was confusing for me at the time.
Yeah, for me also, it was really confusing to understand that there are some different networks, and then, for example, it was hard to me to understand that, okay, I have my wallet address, and then if somebody sends me some ether on the mainnet, and by accident, if somebody sent me this either on the Polygon or some other chain, how it's possible that I can still control this same wallet on the different networks. That was something that was bit confusing to me, because back then I had to read that, okay, the wallet address is basically a key par and the cryptography, and that's why I can control still the wallet no matter on which network, because I'm the owner of the private key, right? And that was something at the beginning hard to understand, because I thought about wallet addresses more about API keys that are generated in some centralized way, that I thought like, okay, if I'm generating some wallet on the one network and in another, then basically there is always some state attached to this wallet, and that was something that on the beginning was quite challenging for me.
Yeah, for me, chains and that the fact we have so many chains, that was the most confusing for me. But sorry, I didn't get your the question correctly, so I answered your question referring to my very old times when I started in IT, not in Web3. So
Yeah,
but yes,
I meant at the beginning of the Web3, let's
yeah,
say.
Web3 journey.
Yeah. That,
Yeah. So
uh,
the number of chains, how many chains, and what that some chains are similar, some chains are EVM compatible, some other are not. We have we have Ethereum, we have blockchain. It's not compatible at all. We have Atom, we have Polkadot ecosystem. There is a lot of chains because that was in fashion at that time, 2 years ago, to talk about different blockchains, and we get new blockchains every few days, and that was really confusing to me. But I like you to remember from this session that let's focus on EVM compatible chains. That's I in terms of test chains, I recommend you to look at Sepolia and Gerli, and also layer 2 blockchains like Polygon, Arbitrum. Is Avalanche L2 also?
mm, SL2 or sidechain, I don't really know.
Is sidechain or L2? The difference is it's not important. Just focus on EVM compatible chains, because everything we have talked about blockchain today, it refers to EVM compatible chains. Yeah, that was the most confusing part for me.
Yeah, and we
And it
have
still grows.
yeah. So there are more and more chains. Yeah, but I think the same as you, that at least I think that the Ethereum compatible, EVM compatible chains have the future, because that's where there are most developers focused on. And I think that's quite connected to the question from the chat. What about smart contracts developer? Should I focus only on Solidity, or maybe try others blockchains like Cosmos, for example? So there are two approaches to that. One is focus on the most popular thing at the moment, because there are just more tools, more tutorials, more job offers and stuff. And I think I would focus only on Solidity, but there is just another approach that, okay, but on the Solidity there is a lot of competition, and it's a lot of people that already know it. So if you go for some, some less popular technology or some less popular choices, then there's a lower chance of competition on the market, right? So yeah, I think there are these two approaches. I prefer the first one, because if you go for some exotic blockchain or some exotic programming language, then often you might have some situation that the market is even smaller for them. And even if you would be able to find your first job, then if the blockchain would be not successful, or if you would have to change your job, then probably your experience wouldn't be that relevant anymore, because that would be more job offers from different from Solidity or Rust or some more popular approaches. So it's hard to answer it, but yeah, I would go for Solidity. Any thoughts on
Yeah.
that, Kuba?
And my advice is just follow the market, follow the money, look at other developers where they go through. So for me, the Ethereum mainnet is the leader, and every new blockchain which starts in that competition is on the starts from the lower position. So if you can find a project who performs on EV on Ethereum mainnet or any layer to any sidechain for Ethereum mainnet, that's the that's the good choice. Maybe not perfect bet, but the good choice. Yeah, market grows every day, and it's really easy to fork any blockchain and create a new one, but we need to build the market, not running smart contracts, not running validators only in the one computer. We need to build a network. We need to build a community and to take profits from that, because we can take profits when the network grows. There is no other way.
Okay, so thank you, Kuba, for your time. Thank you for the questions from the chat. If you would like to stay connected with us, just check the description of this video on the YouTube. If there are no links now, then we'll update it within some minutes afterwards, so you can always find us there. Some links to our LinkedIn, Twitters, and so on. If you are watching this video in the future, feel free to leave a like or comment. Let us know what kind of content you would like to see, or any question if you have in terms of Web3 front-end development or smart contracts, then feel free to ask and we'll get back to you, or just record some new material that will cover these topics. So thank you guys for your attention, and see you next time. Thanks, Kuba.
Yeah, don't forget to feed YouTube algorithm and catch me on Twitter.
Sure.